Good morning and welcome to the webinar Successfully Integrating Direct Drive Technology into Your Machines. My name is Matthias Beetz and I'm moderating today's webinar. Your speaker is Markus Keiler. He will hold the webinar and answer your questions afterwards. In today's webinar, you will find out why direct drives offer many advantages in the long term and in which cases a change is worthwhile. Which applications can be implemented with torque motors, which drive options are available to choose from, and which mounting options exist for integrating on the machine. Before we begin our webinar, I want to let you know that you will be muted during the webinar. You have the possibility to ask us questions via the chat function at any time during the webinar. You will find the button for the chat function in the bottom right corner. The questions asked in the chat will then be answered in a question and answer session at the end of the presentation. We have planned about 10 minutes for this. We will record the webinar and the link to the recording will be sent to you by email. A few words about Baumüller. Baumüller is a globally positioned family-owned company with more than 90 years of experience in its core business of drive and automation systems used in many industries. And now I will hand over to our speaker, Markus Keiler. He has years of experience in motor technology. I wish you an exciting webinar.
Yes, thank you very much, Matthias, for your opening words. And also I will welcome you to today's webinar. Now I would like to show you all today's agenda. First, we talk about direct drive technology and what it means. Then I will have a calculation example for the life cycle costs. After this, we have a deeper look in the mechanical versions and mounting options for our DST2 motors. And last but not least, we will have a summary of today's webinar. So let's start. Direct drive technology means that the motor power is transmitted directly and without intermediate components to the mechanical unit that is being powered. You can see the conventional solutions, belt drive, hydraulics, and gearboxes solutions on the graphic on the left. We want to break away from this and enable a direct drive with slowly rotating high torque motors. This has many advantages. We have a compact design, less wear, lower noise emissions. I will have a slide for this example. We have improved dynamics. We have a high system stiffness, so that means no backlash in the drive and the transmission omitted. For example, we have lower costs, less maintenance work, and a better overall efficiency. So all in one, reduced life cycle costs. And this brings me to the next few slides where I have a calculation example. The degree of efficiency results from dividing the output power through the input power. Here is an illustration of a motor. Simply put, we add electrical power to the motor and get a mechanical power in the form of a rotating shaft. However, you can see in the red arrows that an electrical motor hasn't 100% efficiency because there are also losses. We have current losses, iron losses, and additional losses. This example relates to the direct drive technology. If you will add a gearbox to the axis, the loss analysis looks like this. There are additional friction losses caused by the transmission. We have an operating point for this calculation example. The operating point has 1,100 Newton meter, and an effective speed of 450 RPM. By taking a look into the left gap, we see the motor gearbox combination. To calculate the whole efficiency, we need to multiplicate the efficiency of the converter with the efficiency of the motor and also with the efficiency of the transmission. In this case, we get 82% efficiency. In the right gap, we see the direct drive. Here, we do not need to multiplicate a factor for the gearbox because we do not have any gearbox. This and also the better efficiency of the motor itself results in a higher efficiency factor. Overall, we can increase the efficiency by 6.4%. And this example is only for the full load range. At part load, the efficiency of the torque motors increase again significantly. For our example, we have a shaft power requirement of 51.8 kilowatt, and the operating hours per year are 7,000. To get the energy demand per axis and year, we need to multiplicate the operating hours with the required shaft power. In this case, we have 362,600 kilowatt hours. Now we want to know which energy costs this results. So we need to multiplicate the energy demand with the energy costs for 1 kilowatt hour and divide it through the efficiency. This results in 98,256 euro energy cost for the motor gearbox combination. We saw that we are able to increase the efficiency by using direct drive technology. Basically, the calculation is the same. We have just to adapt the value for the efficiency. Now we see the energy costs are 92,291 euro. Overall, we save 6,000 euro energy costs per year. On the other hand, to the saving of the energy costs is of course also a saving of carbon dioxide emissions. Now we want to go deeper in the mechanical versions and the mounting options for the DSD2 motors. Here you can see the mechanical versions of our high torque motors. We have the solid shaft version, the hollow shaft version, the thrust bearing version for plastic industry, for extruders, and we have a special version, the kit. To briefly go into the inner values, these motors are high-poled synchronous motors. Highly poled for the reason that you need high torque at low speeds to replace motor gearbox solutions. Our torque range starts from 140 Newton meter up to 60,000 Newton meters. We start with the solid shaft version of the motor. Here you can see a nice application example in which the motor is installed on an injection molding machine by a coupling. This example is of course only intended as an illustration and can be multiplied to any other industry. A coupling has different advantages. It's easy to mount, almost maintenance-free, extremely compact, high transferable torques are possible, good damping properties, and also good balancing properties. But of course, it has also some disadvantages. Reduced stiffness in the drivetrain. Depending on the type and operating, we have backlash due to the elastic elements, which you can see here in red. And we depend on the type. It's also because of the elastic elements. Here you can see an additional application example for the coupling. We have a tablet press which is used in the medical industry. Here is our motor, and it's connected inside of the machine. Now I would like to bring you closer to the different mounting options for our hollow shaft motors. The clamping set forms the beginning. A clamping set is an interface fit shaft hub connection that is mounted within the hollow shaft. The tapered clamping elements, which you can see here, are pressed together, and in this way they establish the connection between the hollow shaft and the shaft of the machine. The force will go to both shafts, the hollow shaft and the machine shaft. You can see it also here with these arrows. Here you can see how the clamping set is mounted inside of the hollow shaft. Additional centering of the machine shaft is achieved by an centering ring. The advantages are cost efficiency, excellent smooth running characteristic, backlash-free, and high transferable torques, what is necessary for our high torque motors. As the disadvantages, I can say it could be additional centering, which is necessary, and due to radial clamping forces, the hollow shaft must have a wall thickness sufficient to prevent damage. Shrink discs are external clamping elements for backlash-free fixing of shafts. This brings us to the main difference of the clamping set. The shrink discs are outside of the motor, and the force acts only to the machine shaft. Here you can see how it is mounted outside of the motor. Here in this slide, we can see the flange ring of the shrink disc. The flange ring can be easily mounted to the motor shaft with these holes, and here is the hole for the machine shaft. As advantages, we can say no imperceptible cramping force within the motor on the hollow shaft, excellent smooth running characteristic, backlash-free, and high transferable torques. The disadvantage is that the mounting option results in additional overall length. Here we can see also an application example for the shrink disc. We have a hybrid ship solution system. Here's the diesel engine, and here you can see our motor, and the shrink disc is here mounted to the motor and connects the machine shaft with our motor. Now let's take a look to the ball screw. The ball screw nut is driven by the rotor and also connected to the rotor. In this way, it is possible to translate the rotative movement of the motor into a linear movement. Because the motor bearings cannot handle the produced axial forces, they need to be absorbed by a machine construction. Here you can see a little screenshot how it could be. We will have it more in detail. The advantages are very high position and accuracy, high traversing speeds, high transferable torques, and compact installation space because the spindle can plunge into the hollow shaft. As disadvantages, as I said, axial forces must be kept away from the motor shaft design, high production cost because such a ball screw is very expensive, and grease deposit on the motor is possible due to the spindle. Here I can show you the application example. We can see an injection molding machine. Here is our motor, and This is the moving plate of the injection molding machine. So with the motor, the moving plate goes opens and closed the machine. Now we come to the thrust bearing motors. Thrust bearing motors were specially designed for use in extruders. The extruder screw is directly coupled here with the blind hole of the motor, thereby exposing the motor to high axial forces. These forces are absorbed by the integrated spherical roller bearing, which protects the motor from damage. I can show you here the details. You can see the motor looks a little bit different to the other ones because there is a very, very big bearing in the drive end to handle the axial forces of the screw. Here you can see the bearing in detail. The axial forces acts axially, of course, and is covered with over the bearing to the motor. Here we can see a blow molding machine. You can see two extruders with the direct drive technology with Baumüller motors. With the next two pictures, we see a little bit more details. The whole machine has not only two extruders, it has 6 extruders. And here we can use the benefits of the noise reduction. This brings me to the next slide. In the beginning of the webinar, I told you that we are able to reduce the noise emissions with direct drive technology. Here you can see a diagram. The x-axis shows the extruder speed. The y-axis shows the sound level. Both green lines are motor gearbox combinations with two different materials. The orange lines are torque motors with the same materials. By looking to 125 RPM, we see that the sound level is reduced about 20 decibel. And it's of course just for one extruder. In our example we saw we have 6 extruders. This happens because we have slowly running direct drives and also they are water cooled, and this reduces the noise level of the axis. Okay, then let's come to the summary of today's webinar. We have a greater machine output and thus higher productivity. Reduced downtimes due to high robustness and lack of maintenance of the system. No or short maintenance cycles. This means we do not have to maintenance gearboxes. And of course, this is also a point which can be multiplied to the life cycle costs. We have higher energy efficiency. I had a calculation example for this. We have also smaller footprints because we do not have the gearboxes, and we have lower noise emissions. Okay, thank you very much for your attention. Now I would like to hand over again to Matthias.
Yeah, Markus, thank you for your interesting presentation. Now let's move on to answering your questions. I'm looking to the chat function and I can see we have some questions. The first question is, you have only mentioned running costs in your presentation. How are the investment costs on direct drive applications compared with traditional gearbox solutions?
Yeah, thank you for the question. It's a very good point. The first costs are a little bit higher with the torque motors compared to the motor gearbox solutions, but I only had one point for the energy costs, where you have the return of invest very quick with the during let me say 2 years, for example, you can calculate or add the maintenance costs, which are not necessary because you do not have to maintain any gearbox, for example.
The next question we have, please elaborate a little around the impact of inertia ratio in direct drive applications compared with traditional gearbox solutions.
Yeah, we have a very good inertia. The motors are dynamic compared to motor gearbox solutions because, yeah, with the gearbox you have rotating elements, and those rotating elements results in a higher inertia. And we have with the DST2 motors, with the direct drive technology, a very dynamic solution.
We have a next question. How could we make the retrofit of our current systems?
Yeah, it's also a good question. So the best would be to get in contact with us and our engineers, and we have to look about the application, which application is it, and then of course we need the cycle times of the machine to make the best sizing of a torque motor to replace the motor gearbox combination. But here we can help you in an additional meeting because that's our daily business.
So you need a lot of technical data of the machine. I understand not only the cycle time, the torque, yeah, everything what is necessary, yeah, for the process, for the complete process in the machine. I understand.
Yeah, that's right. Thank you, Matthias.
Yeah, we will give you the contact person. This is no problem for us. You can email us, and so we can give you the contact person. Of course, we will do it. Yeah, the next questions we have, are the torque motors only water-cooled?
By standard, the motors are water-cooled, but of course it is possible to run the motors without a water cooling system. But you have to notice that we will have, the motor will see a derating factor in this case. But it is possible to run the motors without a water cooling system.
The next question we have is, when to use which motor shaft option?
Also a good question. This depends also to the application and the machine. So with our shaft options, we have the possibility to enable the customer the right solution for his construction type. Sometimes this is necessary to have a hollow shaft because we saw a spindle is through the hollow shaft, and sometimes it's okay to have a solid shaft with a coupling. So we have the right solution, and it depends on the application.
Okay, I'm looking again into our chat, and we have the next question. Can it also be useful to operate a torque motor in connection with a transmission link, for example, with a gearbox or a belt?
Very interesting question again. Yeah, it could be useful because I have an example maybe for a shredder. We run the shredder with a torque motor. Of course, we would have a torque motor and torque range to run directly the shredder shaft. But if you use here a belt drive, you have the benefit that the process forces which are very hard in a shredder are the motor does not see the process forces. So the belt drive is here a benefit to for the motor itself. Or another application example would be a servo press. Here we have very big motors with 60,000 Newton meters, for example, with the highest axis high. And the motors are connected to a gearbox because the torque level of an servo press is very, very high. And with the high torque motors, the customer has the benefit that the gearbox itself is smaller.
Yeah, Markus, thank you very much for this interesting information. I'm looking to the chat and I cannot see further questions. Thank you so much for your questions. If you have any further questions, please feel free to email us at marketing@baumüller.com. We will then answer your questions in the follow-up. Further interesting information on our webinar can be found on our website under Baumüller Insights, among others. Thank you for your attention and stay healthy.